गुड मॉर्निंग डियर स्टूडेंट्स। मैं डॉक्टर नीलम गुप्ता बीएससी पार्ट 2 के विद्यार्थियों के लिए डिस्ट्रीब्यूशन ऑफ मॉलिक्यूलर वेलोसिटीज का मैक्सवेल लॉ पिछली क्लास में मैंने पढ़ाया था, जिसमें हमने यह निकाला था नंबर ऑफ मॉलिक्यूल्स हैविंग द वेलोसिटीज बिटवीन सी टू सी प्लस डी सी कितना होगा, डीएनसी, जिनको हमने रिप्रेजेंट किया था। जो डेरिवेशन या जो एक्सप्रेशन हमने मैथमेटिकल एक्सप्रेशन हमने मॉलिक्यूलर डिस्ट्रीब्यूशन ऑफ वेलोसिटीज का नंबर ऑफ मॉलिक्यूल्स हैविंग द वेलोसिटी बिटवीन द रीजन सी टू सी प्लस डी सी निकाला था, उसमें हमारे पास जो इक्वेशन आई थी वो इक्वेशन मैंने लिखी थी, ये डिराइव करी थी डीएनसी से। हमने उसको नंबर ऑफ मॉलिक्यूल्स को डिस्कस किया था। That will be equal to 4 pi na cube e raised to the power minus bc square c square dc। उस एक्सप्रेशन में यदि हम देखें तो हमारे पास दो कांस्टेंट्स हैं a और b। सो हमको जब तक इन कांस्टेंट का मान नहीं पता चलेगा हम नंबर ऑफ मॉलिक्यूल्स को निकालने में या बताने में सक्षम नहीं होंगे। तो आज हम निकालेंगे कि नंबर ऑफ मॉलिक्यूल्स पर यूनिट वॉल्यूम C से C प्लस DC रीजन में जिन मॉलिक्यूल्स की वेलोसिटी C से C प्लस DC के बीच में लाई करती है, उन मॉलिक्यूल्स का नंबर कितना है। सिंस हम कंसीडर कर चुके थे कि द नंबर ऑफ मॉलिक्यूल्स पर यूनिट वॉल्यूम यदि n है, तो यदि मान लो हम जो इक्वेशन है नंबर ऑफ मॉलिक्यूल्स की उसको यदि हम इंटीग्रेट करें, देन वी कैन कैलकुलेट द नंबर ऑफ मॉलिक्यूल्स पर यूनिट वॉल्यूम हैविंग द वेलोसिटी बिटवीन C to C plus DC। So we have just considered the last previous equation that dNC is equal to 4 pi na cube e raised to the power minus bc square c square dc। We have the two constant a and b, so here we will calculate the value of these constants a and b after integrating this equation for the unit volume. So this n is equal to, the space is extended, or velocity of the particles can be extended from 0 to infinity. dNc is equal to 4 pi na cube integral from 0 to infinity e raised to the power minus bc square c square dc। This integration is a definite integral, so directly we can write down the value of this definite integral. That will be equal to 1 upon 4 pi b cube to the power 1 upon 2. So n will be equal to 4 pi n a cube 1 upon 4 pi upon b cube to the power 1 upon 2. So since this integration is this, so after simplifying this equation, a cube will be equal to, because this n will be cancelled out with this n, and a cube will be equal to b upon pi to the power 1 upon 2. So this is the value of constant a, or we can say a is equal to under the root b upon pi. Since the molecule per unit volume moving along the x-axis and having the velocities in between u to u plus du, then the number of probability or number of particles having the volume, having the molecules per unit volume moving along the x-axis is represented by nu, and that will be equal to n fu du. So by substituting the value of fu du, we have n is equal to a e raised to the power minus bu square du. Now we consider if the mass of every particle is m or molecule is m, then the pressure exerted by the molecule on the wall normal to the x-axis, क्योंकि हम जानते हैं कि किसी कंटेनर में हमने गैस मॉलिक्यूल्स को रखा है और गैस के मॉलिक्यूल्स जो है वो रैंडम डायरेक्शन में रैंडम वेलोसिटी से मूव कर सकते हैं। जब गैस के मॉलिक्यूल्स आपस में टकराते हैं तो भी एक दूसरे के ऊपर प्रेशर एक्सर्ट करते हैं, और कंटेनर की वॉल के साथ भी जब टकराएंगे, कोलिजन होएगी, तो भी वो प्रेशर एक्सर्ट करेंगे। तो हमने कंसीडर किया कि जो भी मॉलिक्यूल्स अलोंग द एक्स एक्सिस मूव कर रहे हैं वो उस कंटेनर की वॉल के साथ पर नॉर्मली उसके साथ कोलिजन करेंगे, तो वो वॉल के ऊपर कितना प्रेशर एक्सर्ट करेंगे। So that will be equal to P is equal to summation of 0 to infinity nu twice of mu square, because the change in momentum per collision is equal to mu, because the particle is moving along the positive x-axis with the velocity u and mass of the particle is m, so momentum is mu. But the simultaneously particle will also move after collision along the negative x-axis, so the change in momentum per collision is twice of mu, because mu minus of minus mu, that will give you the change in momentum per collision, and the number of molecules colliding per second in unit area is u and u. So after integrating this, we have P is equal to integration from 0 to infinity to m n a e raised to the power minus b u square du. Again the integral of e raised to the 0 to infinity e raised to the power minus b u square du, that will be equal to 1 upon 4 pi upon b cube to the power 1 upon 2. So P is equal to 2mna 1 upon 4 pi upon b cube to the power 1 upon 2, but we know as a is equal to under the root b upon pi. So after substituting the value of a in this equation, we have P is equal to mn upon 2b. If we consider the equation of state, then we know P is equal to nkt, or substituting the value of P is equal to nkt is equal to mn upon 2b. After simplifying this, what you will get, you just note it. The B is equal to m upon 2 kt, or it can be written as beta upon 2. So simply we can say beta is equal to m upon kt. Substituting these equation number 1 and 2 in the equation number 13 of the previous section, day before yesterday I had taught you about this equation. So you can substitute the value of a and b in that equation. So that will give you that d and c is equal to 4 pi n m upon 2 pi kt to the power 3 by 2 e raised to the power minus of mc square upon 2 kt c square dc. Now this equation 3 is represent the Maxwell's equation of Maxwell's law of velocity distribution. This equation presents the number of molecules per unit volume having the velocities range between c to c plus dc. So if we calculate, or if we consider the probability of molecule having the velocity in between the range c to c plus dc, that will give you fc dc is equal to dnc upon n is equal to 4 pi m upon 2 pi kt to the power 3 by 2 e raised to the power minus of mc square upon 2 kt c square dc. This n will be taken out from right side to left hand side, so this will become dnc upon d, and it will give the probability of the molecule having the velocity between the range c to c plus dc. Now we consider the density of the velocity dots in the velocity indicator diagram. So we know the density rho is equal to na cube e raised to the power minus of vc square. That means rho is equal to n into m upon 2 pi kt to the power 3 by 2 e raised to the power minus mc square upon 2 kt. This equation is known as the velocity distribution function. This velocity distribution function is plotted as a function of c. We'll take the c along the x-axis and this velocity distribution function along the y-axis. The behavior of this is shown in this figure. So dnc upon dc gives the value of, given by the equation number 3, is now known as Maxwell distribution function, and it is plotted as a, as we know c is always positive. So this is shown in the figure. Now this is shown in the next figure. Now we consider this figure 2. The curve shown in this figure starts from the 0 as c is 0 due to multiplier c square. In equation number 3, this function dnc upon dc increases as velocity increases and it becomes maximum. You are observing here, ग्राफ में आप देखिए जैसे जैसे हम c का मान 0 रखते हैं, ये 0 है फंक्शन, C का मान बढ़ाने पर ये बढ़ता है और ये बहुत तेजी से बढ़ता है, क्योंकि एक्सप्रेशन में हमने देखा कि इसका मल्टीप्लायर C² भी साथ में है। एक सर्टेन मैक्सिमम वैल्यू के पश्चात इनकी संख्या, इस फंक्शन की संख्या, इस फंक्शन का मान गिरता है, क्योंकि वेलोसिटी जो है वो फर्दर इंक्रीज हो रही है। The number of molecules having the velocities in between the strip C to C plus DC, इसको हमने इस चित्र में दिखाया है इस शेडेड स्ट्राइप से। The area under the curve given the total number of molecules, the variation of DNC upon DC with 3 different value of C is shown in the next figure. These curve shows that the temperature decreases. As the temperature decreases, the maximum of the curve also decreases. As we decrease the value of temperature from T1 say T2 and T2 to T3, we are observing that the maximum value of this is also decreases corresponding to decrement of the temperature. So this is the behavior of the Maxwell distribution function with respect to time, or with the increase or decrease the value of C. Now we consider the application of Maxwell distribution function. About the application of the Maxwell distribution function, we consider the average speed. We know that the average speed of the molecule is mathematically denoted by the expression like the C bar is equal to 1 upon n integral 0 to infinity C dnc. But dnc हम already निकाल चुके हैं, so dnc is equal to 4 pi n b upon pi to the power 3 by 2 e raised to the power minus bc square c square dc. हमने C एवरेज में DNC की वैल्यू रख दी। देखिए क्या हुआ, 4 पाई b अपॉन पाई टू द पावर 3 by 2, इंटीग्रेशन में C² ऑलरेडी था, बिकॉज ऑफ दिस C we have the CQ. Now we'll consider a table of the definite integrals like this. I'm sorry. So when n is equal to 0, the integral 0 to infinity x to the power 0 is 1, e raised to the power minus bx square minus 0 is 1. So in that case, if we consider in this form, xn is equal to 0, then we have 1 upon 2 pi upon b to the power 1 upon 2. If we have n is equal to 1, the integral value is 1 upon 2b. If we have n is equal to 2, we have the integral value of 1 upon 4 pi upon b cube to the power 1 upon 2. If we have n is equal to 3, the value is 1 upon 2b square. If we have n is equal to 4, the value of this integral is 3 upon 8 pi b5 to the power 1 upon 2. So in our expression, we have the n is equal to 3. So in that case, the value is 1 upon 2b square, the value of integral. So C average is equal to 4 pi b upon pi to the power 3 by 2, 1 upon 2b square is equal to 4 upon pi b to the power 1 upon 2, or b is equal to m upon 2 kt, or C average is equal to 8 kt upon pi m to the power 1 upon 2. Now we consider the root mean square speed, square of the mean of the square of the speeds of the molecule in the system is known as the root mean square speed. It is also denoted by CRMS. So CRMS is equal to C square average to the power 1 upon under root 2. So 1 upon n integral 0 to infinity C square dnc. Now in our integral expression, we have C की power 4. So by substituting the value of integral C की power 4 terms में, so C square RMS is 3 kt upon m, or CRMS is equal to under the root 3 kt upon m. The next one is most probable speed. Most probable speed is that speed with which the maximum molecules move in the system is called as the most probable speed. At the most probable speed, C is equal to Cm, the probability of the molecule should be highest. So del Fc over del C should be equal to 0. By substituting the value of Fc and differentiating with respect to C and simplify the equation, we get C is equal to 1 upon B to the power 1 upon 2. So the most probable speed C is equal to Cm is equal to under the root 1 upon B. Or after substituting the value of constant B, Cm is equal to under the root 2 kt upon m. So we have the ratio of these speeds in this form. This is the very important result. Cm or C average or CRMS, most probable speed, average speed or RMS speed. This is the result of these three speeds. So the ratio of most probable to the average to the root mean square speed is equal to 1 raised to 1.128 raised to 1.224. This is the behavior or comparison of all these three speed. The most probable speed is the maximum one, after that the average speed, and then it the root mean square speeds. Now we consider, and so in the next class we will consider the energy distribution function. So that's all for today. Thank you.